Okay, babies, Unit 1 notes. We are continuing through the bottom of page 1 now. If you'll recall from your parent function video that I did, I told you that we would talk more about those characteristics of the parent functions, and that's what we're going to do right now. I know you're excited. Try to calm down. Okay, so let's look at some common information that we can observe from our graphs. So these are physical characteristics that we can actually witness when we're looking at a graph. So I'm going to show you a little bit about this. So the domain should be familiar to you. The domain are your x values. And remember, when you're thinking about domain, if you're looking at the xy coordinate plane, your positive x values are right here, and your negative x values are right here. And the positive ones continue on this way, and the negative ones continue on that way. So when you're thinking about domain, you're thinking about the x values. The range, of course, that's going to be your y-axis, your y values. So our positive values continue all the way up here, and our negative values continue all the way down here. So when we're talking about the domain and the range, and I'm going to get into notation a little bit here in just a moment, or probably in another video. When we talk about interval notation, you should all be familiar with this. It's a series of parentheses and brackets that they were just used to show a range of values. So we'll talk more about that. I believe it's on another page in the notes. So some other things, some other behaviors that we can see in our graphs. Well, we can tell if they are continuous or not. That means there aren't any holes, gaps, or breaks in the graph. A good way to think about something that's continuous is if you can draw it without picking up your pencil. Discontinuous, of course, is the opposite of that. A discontinuous function or a discontinuous graph does have gaps, holes, or breaks in it. And if you'll think about the parent functions, going back to that video, some good examples of discontinuous functions would be the reciprocal function and also the greatest integer function. Those are both great examples of that. So that's discontinuous. Increasing, this one can get tricky because you have to pay attention to the physical movement of the graph. So as you're looking at a graph, let's say I've got my XY coordinate plane here, and I'm just going to draw something silly. All right, so when you're looking at this, notice that it's increasing. We read it left to right. We read it this way, just like we would a book. So if you'll notice this, I'm going to use a different color here. If you'll notice, it's increasing here and here, but it's decreasing. I better use a different color. It's decreasing from here to here. So physically, are you seeing movement both left, right, and up, down? Because we're moving in a diagonal. Sometimes that's going to happen. But what you have to be careful with is when you talk about how far it's moving, how much it's increasing and decreasing, we use interval notation and we only use the x-axis as reference. So we're not using the y-axis, we're using the x-axis. So when you think about the x-axis, remember that the x-axis this way is negative infinity and this way is positive infinity. So this right here would be increasing from negative infinity all the way up to this x value right here. So we'll practice more with that, but that's just a general idea for you. And then, of course, decreasing from left to right using interval notation and the x-axis. Constant, that just means it does this, just remains constant. That is what that's going to look like. So we are going to fill out a parent function from just a blank, and we're going to address what all of these physically do in the next video.